Hey guys, this is Coach Lowe and this is Contextual Geometry, and we are in Chapter 9, Section 4, Proportional Parts and Triangles. All right, so as we look through this in this lesson, some of the things that we talk about, we actually have talked about in previous videos or classes as we did the little sorting game in class. Some of these things you'll be like, oh yeah, I remember talking about that. All right, so let's get started. Let's start with Theorem 9.4, and it says, if a line is parallel to one side of a triangle and intersects the other two sides, then the triangle formed is similar to the original triangle. So we kind of looked at this yesterday and talked about it. Let's see if I can get a triangle here going. So if a line is parallel to one side of the triangle, so let's say these are parallel, we talked about angle-angle similarity yesterday because, or previously I should say, because these two parallel lines, if you extend them out and cut this transversal through, we have corresponding angles here, and we know that corresponding angles are congruent. Right? And then if you do the same thing, parallel lines, and then use this side cut by a transversal, corresponding angles. So we have angle-angle similarity. So we know that triangle ABC is similar to triangle DBE. So what does that tell me from here? Well, it tells me that my sides are proportional. So AB over DB is equal to BC over BE is equal to AC over DE, which means if I'm missing, if they give me three things and I'm missing a fourth, I can pair these two guys together and solve, these two guys together and solve, or the first and the last together and solve, because they all should equal the same ratio. All right, they'll have the same scale factor. So this triangle is similar to the original triangle before I drew the line parallel to the base. All right, so make sure you have that in your notes. And then also, if you want the third angle, angle B is congruent to itself, right? So angle BAC congruent to BDE and BCA congruent to BED. That was our angle-angle similarity. And of course, reflexive property B is congruent to itself. So we could have used that one as well. All right. So let's go ahead and grab, let me give you one more theorem actually before we do that. Let me give you one more. We'll just get the theorems out of the way and then we'll roll with some problems. Theorem 9.5. Theorem 9.5 says if a line is parallel to one side of the triangle and intersects the other two sides, so it starts the same way as 9.4, so if you just want to copy that down, then, so just like 9.4, then it separates the sides into segments of proportional length. All right. All right, so you know how to remember how to spell separates? Separate. That's how I remember. I don't know. I just thought I needed to tell you that. All right, so if a line is parallel to one side of a triangle and intersects the other two sides, then it separates the sides into segments of proportional length. So let's draw a picture of what that looks like. All right, so there's my triangle. There's my parallel line touching the other two sides parallel to the base, intersecting the other two sides. So here's my I think I did A right here last time. So A, B, C, D, and E. All right, so it says if AC is parallel to DE, then my sides are proportional. So that means that AB over AD, so this piece is to this piece as BC is to CE. So AB is to AD as BC is to CE. All right, so we could set up those proportions, and I know some of you guys on previous problems wanted to use this little trapezoid down here so bad. Okay, so we get to use it today. All right, so we have the proportions where we can go triangle to triangle after we get the angle-angle similarity out of the way, and now we can, as long as these guys are parallel, now we can look at these segments and set up proportions with them. All right, so now let's look at some problems. All right, so checking these out, I see that these two lines are parallel to each other. So several things that I could do here. I could say 12 is to 20 as 15 is to 15 plus x, and I can solve. All right, so let's try that. So it doesn't matter what these numbers are, does it? We don't care. So little triangle to big triangle, little space, little triangle side to big triangle side. All right, so go ahead and pause the video and try that out. All right, so I reduced this guy, and I took out a 4, so that's 3 over 5 equals 15 over 15 plus x. So cross multiplying here, putting parentheses around this, I have 45 plus 3x, multiplying 3 by 15 and 3 by x equals 75. Subtracting 45 from both sides, and then dividing by 3, x is 10. Now that's using Theorem 9.4. Theorem 9.5 says that 12 over 8 equals 15 over x. So you can either use Theorem 9.4 or you can use Theorem 9.5. All right, so if we use this one, let's go ahead and reduce this guy. So dividing both of them by 4, and now cross multiplying, I get 3x equals 2 times 15 is 30, or x is 10. So either Theorem 9.4 or 9.5 works on that. So awesome. All right, let's look at number 14. Which theorem do you think we should use on this one? So they gave me 15 and x and 30 and 42. Well, you can actually use either one because I can find this little piece right here. If the whole thing is 42 and the little piece is 30, then this has to be 12. So 15 over x equals 30 over 12. And let's go ahead and reduce this guy by 6. So 6 goes into 30 5 times, and 6 goes into 12 2 times, and then let's cross multiply and solve. So crossing this way, x times 5 is 5x, 2 times 15 is 30, so x is 6. All right, let's try number 15. And if you want to pause the video and try these on your own, please do that. All right, so number 15. They give me the small triangle side and then the big triangle side, and this time it's x, so I can't do what I did over here. So I'm going to have to do little triangle to big triangle, which is totally fine. So 18 over x, so little side to big side equals little side 36 over big side 50. All right, so I think we can reduce this as well, maybe by 2 on both of them just to make it a little bit easier on us. So 18 over x equals 18 over 25. Okay, now let's be smart about this. If the tops are both 18, then the bottoms both have to be, 25. So x is 25. Nice job. All right, so go back to Theorem 9.5 now, and next to Theorem 9.5, I want you to draw a star next to it. Okay, so just to the left of where you wrote Theorem 9.5, just put a star. All right, okay, let's do one more. Let's see, how about number 18? We'll squeeze it right here. All right, so again, we can either use Theorem 9.4 or 9.5. So let's do 9.5. I think that's probably a pretty good one. I like to use Theorem 9.4 when I'm given things like this, where it gives me whole pieces and variables, and you can't use the other one, then 9.4 comes into play pretty well. All right, so you can pause the video and set this up, totally fine, and then come back and let's work. So 9 over 12, so this piece over this piece equals x over 21. Let's go ahead and reduce this guy. Let's go ahead and divide by 3. So 3 over 4 equals x over 21. And then let's cross multiply. So 4x equals 63, or x is 63 fourths. All right, so goodness, what is 63 fourths? Off the top of your head, right? All right, so 23, that's a 5. So 15 and 3/4, or 15.75. All right, guys, that's all I have for you today. I'll see you soon. This is Coach Lowe, and I'm out.